All right, guys, lesson 53, last lesson before Christmas break. We are adding and subtracting polynomial expressions. Now, this is really easy. You've done this before. There's nothing new here. But we are going to add some new terminology to it, some new definitions, and some things that you're going to find valuable later in your mathematical life. Just vocabulary allows us to speak math, just like vocabulary in English allows us to speak English. All right? It really does. So as we learn vocabulary, we're going to do that. Now, there's some important concepts that we want to remind ourselves of. We're adding and subtracting like terms, right? If we're adding and subtracting like terms, they must be... Yeah, I just kind of... In order to add two terms, they must be like terms. Now, what are like terms? That's fractions. Same variables with the same exponents, right? So terms with the same variables and exponents. Now, if you have like terms, what is the process of adding the terms together? How do you do it?
Just add the coefficient.
You add or subtract the coefficients.
You don't add the exponents.
You don't change the exponents, right? Right. So when we're adding like terms, the exponents do not change because only blank or blank can change an exponent. Multiplication and division. Of course, we could get into other exponents can change exponents, right? But it's the same thing. Exponents can obviously change exponents, but the only other operations that can change exponents are multiplication and division. So if we're adding or subtracting like terms, the exponents are not going to change. All right? A couple of new definitions here.
Can you write these down?
Yes.
Oh, I remember that.
The degree of a monomial, there's not a lot of notes to take today, but the degree of a monomial is the sum of the exponents of its variables. All right? The degree of a monomial is the sum of the exponents of its variables. Where have y'all heard the term degree before?
Like an angle.
Degrees, but in algebra, where have you heard the word degree?
Angle. This is like first degree, second degree, like
Like
and stuff like that.
Yeah.
First degree. So what else? What else have we talked about?
First, second, and third.
Yeah, we talked about it at the very beginning of the class. We said the fundamental theorem of algebra tells us that an nth degree polynomial has n solutions, right? So with multiplicity, but the degree of the polynomial is important. It tells us a lot about the polynomial. So the degree of a monomial is directly related to the degree of a polynomial. The degree of a polynomial is going to be the highest degree of its monomials. Okay, so the process for finding the degree of a polynomial is to find the degree of each term and choose the largest one. Okay, so the degree of a polynomial is the highest degree of its monomial terms. Yes?
For mine, well, half. I can't understand. But since mine was one, would that mean there's just one answer? Or
One term,
one term?
right? One term. Monomial is one term. Polynomial is one or more, right? A monomial is a polynomial, but it's the special kind. So we have monomials, binomials, trinomials, and then the rest of them are just called polynomials. Okay, but we can classify polynomials based on the number of terms. We can classify them based on the degree. So we can have a third degree binomial. Right. We can talk intelligently about those things if we have these definitions. If we don't, we can't speak the language. All right, so let's practice finding degrees quickly. What would the degree of this term be? Go back to the definition. What does the definition say to do? Sum of the exponents of the variables, right? So what would the degree be? Why would it be 6?
2 plus 1 plus 3.
Yeah, because the understood 1 on the y, right? So 2 plus 1 plus 3 gives us a degree of 6. All right? Okay, what about this one?
4.
It's 4 degree. Again, we have this understood exponents of 1 with the y and the z, and the 1 and the 2 and the 1, 2. Oh, sorry. The 1 and the 2 and the 1 gives us a degree of a 4. A 1 and a 2 and a.
Oh man.
All right. What about this one?
5.
4, 5.
5. That would be
That's
5.
But that's very.
But you silly goose, that's not very many 5.
Silly goose?
Yeah, goose. Like a still be silly goose.
All right. So the degree here is 5. And what you have to be careful with is we don't count the exponents of coefficients. Like 12 is 144, and this AB cubed C. So if I chose to write 144 as 12 squared, yeah, it's still, I could choose to write it as 3 squared times 4 squared. That's what 12 squared is. And so the degree would constantly be changing based on how we write our constant. And so we don't consider the degrees of coefficients or the exponents on coefficient when we're finding the degree of the polynomial. All right? It just doesn't figure into play. Okay? Now, standard form of a polynomial. This is our last definition of the day. Standard form of a polynomial is a polynomial whose terms are arranged in descending degrees. Ooh, I left out a word, right? R. A polynomial whose terms are arranged in descending degrees. Okay, what do we mean by descending degrees? The largest degree to the smallest degree, right? So when we do that, we can talk about what is the first term. If it's in standard form, that makes sense. Everybody's first term would be the same, right? If it's in standard form, then we can use those types of that type of language. If it's not specified to be in standard form, then we can't talk about what the first term is. So arranging polynomials in standard form is an important skill. So we can all be on the same page as to what the first term is, what the last term is. Because when you get to the rational root theorem and Algebra 2 and advanced math and college algebra, you need to know the first coefficient and the last term. The first term and the last term tell us a lot about the zeros, the solutions of that polynomial expression. All right, so first and last terms are important. Write each polynomial in standard form, then find the leading coefficient. Okay, so let's first write this in standard form, and then I want to talk about a couple things related to this polynomial. We'll go ahead and pull the next one up too. So letter A, what would letter A be in standard form? N cubed plus 2 n squared. Highest degree to smallest degree. Right? So this term has a degree of 3. This term has a degree of 2. This is called the third degree term. This is called the second degree term. So we can talk about those things intelligently. All right, what's the degree of the polynomial?
5.
It's 3. This is a specifically third degree binomial, right? We could go ahead and call it a binomial. It's generally a polynomial. It's specifically a binomial, right? Isaiah? Elijah? What's the leading coefficient of this term, of this polynomial? The leading coefficient is 1. Okay? All right, what about the next one? Let's arrange it in descending order, and then we can talk about what we're looking at. What is this next one going to be? Sound like some robots. All right. So that's it. What's the degree of this polynomial?
5, 6, 7. What? 7.
So this is a 7th degree term. This is a 3rd degree term. What's the degree of 9?
0.
0. That's right. Don't confuse 0 with nothing. All right. The sum of the exponents of its variables. That's because anything raised to the 0 power is 1. This is 9, x to the 0, y to the 0, z to the 0, if I wanted to write it that way. Because those are all 1s, right? 9 times 1 times 1 times 1 is 9. So it has a degree of 0 because the exponent on it, or the exponent on its variables would have to be 0. Okay? Now, this is a 7th degree trinomial. What's the leading coefficient?
5.
5. Yeah. So those things like leading coefficient, first term, second term, third term, really don't make sense unless we are in standard form. So it's a standardized form so we can talk about things. Now, the directions here say add the polynomials and write your answers in standard form. Add the polynomials, okay? All right, add the polynomials. Now, to combine like terms, we're going to have to get rid of parentheses, and we normally would do that by distributing to get rid of parentheses, but we don't really have anything interesting to distribute here. Now, if there was a 2 in front of this and a 5 in front of this, then we would have some interesting things to distribute. If we're just distributing 1, we may as well not even have parentheses, right? So we've got to add these things like term to like term, right? So those are like. These two are like. This one doesn't have a friend. And this one are like. And when I'm doing this, I'm a teacher. I've been teaching math for 20 years. If I'm working a problem like this on a test key or something like that, I do that. I identify my like terms so I make sure I don't leave anything behind. You know, you might be at some point in a college algebra problem dealing with 9 or 10 different terms. It's easy to leave one behind. So make sure you're identifying everything and going. Now, if we're going to put this in standard form, I want to start with my highest degree terms, which is what? 3, right? Negative 5x cubed. These terms are done. Positive 4x squared and negative 2x squared is positive 2x squared. I'm done with those two terms. All right? And then plus x just comes down because it doesn't have any friends. Plus 1 and plus 7 is plus 8, right? My stylus is not cooperating there. So negative 5x cubed plus 2x squared plus x plus 8. Now, if we have degrees that we're dealing with here, then I could ask you a question like this. What's the coefficient of the second degree term? 2, and you can answer it. Right? And when we get into, when you get into analysis of functions, graphing functions, those kind of things are important. What's the leading coefficient?
Negative 5.
All right, negative 5. Okay, and then what else? What's the constant?
8.
8. Good. All right, next example. Same thing, right? Because we're adding these terms, it's really not important. The parentheses are not important, right? Because there's nothing to distribute. So we can just kind of ignore that the parentheses are there and identify our like terms. Let's start with the biggest one, 2x cubed, the highest degree term. Doesn't have any friends, right? 3x squared also doesn't have any friends. But x and negative 7x, those are like. And then positive 10 and negative 2 are like.
So
That will give us 2x cubed plus 3x squared. X minus 7x is negative 6x. And then plus 8. 10 minus 2 is 8. Okay? This is a polynomial. What's the degree of this polynomial?
3.
Third degree polynomial. What's the coefficient of the first degree term? Negative 6. First degree. 2 is the leading coefficient.
I thought first degree was like from left to right.
Yeah, this is our 0 degree term, first degree term, second degree term, third degree term. Okay? So the constant is 8. Just, you're learning vocabulary so you can communicate, right? All right, just a couple more. What's different about these problems? We have something meaningful to distribute in order to get rid of parentheses, right? So I need to distribute this negative sign here. And that'll give us negative 2x squared. This is negative 2x squared. The stylus is not working. Plus x minus 8. All right, and then you can combine like terms. 6x squared minus 2x squared is 4x squared, right? 4x plus 1x is 5x, and 2 minus 8 is negative 6. This is a second degree trinomial, right? It's called a quadratic. It's a special name, very special type of function. 4x squared plus 5x minus 6 is a quadratic trinomial. It's a second degree polynomial, right? If I turned it into equation, I'm looking for how many answers? 2 answers, because it's a second degree equation, all right? Last one, again, distribute the negative here. That would give us negative 4x squared plus 5x minus 11. X squared minus 4x squared is negative 3x squared. 4x plus 5x is plus 9x. Negative 9 and negative 11 is minus 20. All right? That's the standard form answer. And again, we have another quadratic trinomial. All right? Homework. Last homework of the year.